nomenclature of aryl halides or haloarenes. We will see whenever only one substituent is there, then we don't need to give any comparative number. It is obvious that it is one, and so there is no need of writing one bromobenzene. But if it is in the position like 1, 2, 3, then we may write 1, 3 dibromobenzene, or 1, 3 position is called as meta position. It is called as meta position, or we can write meta dibromobenzene. Now here it is 1, 3, 5. There is no name for two meta positions. It is also meta position, it is also meta position. Okay. So it is named as 1, 2, 3, 4, and 5. So 1, 3, 5 tribromobenzene, and since it is symmetrical in nature, since this molecule is symmetrical from all sides, if you see it this way also it is symmetrical, if you see this way also it is symmetrical, so in all ways it is symmetrical. This way also it is symmetrical. That is why it is called as symmetrical tribromobenzene. Then what could be unsymmetrical tribromobenzene? Unsymmetrical tribromobenzene could be like this. Br, Br, and Br. Here also we can give one Br. So this is ortho, meta, para, bromo, benzene. Okay. With respect to this, or we can name it as 1, 2, 3, 4. This is a hypothetical molecule. So many bromines cannot be there all around. Next, in case of normal alkyl halides, we will apply longest chain rule. So in the longest chain which contains substituent is 1, 2, 3. This is the longest chain. In this longest chain, we will name it as 1, 2, 3. So it is 1 chloro. At 2 position, 2 methyl groups are there. 2, 2 dimethyl, 1 chloro, and for 3 carbons propane. For this 1, 2, 3, 2 bromo propane. Okay. These are just like the revision of previous concepts of naming hydrocarbons of class 11th. There are 2 chapters. You can just go through those 2 chapters once. It will be good. Now, when it is dihalide, it could be JAM dihalide if it is on the same carbon atom, or weak dihalide if the halides are there in the 2 carbon atoms. So ethylidene chloride and ethylene dichloride. Here the 2 chlorine atoms are there on the same carbon. It is much unstable. It is very unstable because 2 electronegative heavy groups are attached with the same carbon. So it rearranges itself. It rearranges itself to this molecule. So if the 2 chlorines are there in the 2 adjacent carbon atoms, we call them as ethylene dichloride or weak dihalide, or 1,2 dichloroethane, else we'll call it as 1,1. Here list of the names are given for your practice. Now there are 2 ways in which you can do the practice of this. You can write down the common name, then draw the structure, and then write the IUPAC name, or you write down the IUPAC name and then write down the structure and then the common name, or you draw the structure and then write both common name and IUPAC name. Okay. So when you will do that, you may do it correctly or you may commit mistake. If you commit mistake, then refer to the textbook again, correct yourself. Okay. So in that way, if I want to make a question, then I can make a worksheet out of it in which I can give you three types of question. Write down the common name of the structures, draw the structures of the IUPAC names given, and give the common name of the IUPAC names given. In this way, I can give you question from this table. So you can practice this table once, pick up your pen and paper and start practicing it. Unless you don't practice, you will not learn. Next, let us take these questions. Now there are 8 structural isomers which is possible for bromopentane. So we have to draw all the 8 structures and name them and classify them as primary, secondary or tertiary bromide. So let us start. First of all, we will make normal pentane. 1, 2, 3, 4, 5 and 1 bromine I'll give. Second, this is understood that hydrogen is there. Second, I can bring this bromine over here. But if I bring this bromine over here, then it will be positional isomer, and positional isomer is also a type of structural isomer. So it is okay. Isomerism in organic chemistry are of two types. Isomers are of two types. Positional isomer, structural isomer, and geometric isomer. Structural isomers can be chain isomer, positional isomer, metamers, and tautomers. Geometrical isomers are stereoisomers, optical isomers, and conformers or conformational isomers. Again, this topic has its base in class 11. Class 11 base. Refer to the chapter. There are 2 chapters of organic chemistry. Do refer to that. Otherwise, organic chemistry will remain difficult. If you refer to that once, it will become easy. And for your reference, although some other chapter is going on in class 11, but I have put up the videos of organic chemistry of class 11 in the playlist. You can search and see. So we are writing down the structural isomers, and in structural isomer, first of all, we'll write the positional isomers. So CH3, CH2, CH2. Now on this carbon, C, Br, H, CH3. This is 1 bromo pentane. This is 2 bromopentane. In one bromopentane, the carbon atom with which bromine is attached, with that only one carbon is attached. That is why it is primary. It is primary halide. But here, with this carbon, two carbons are attached, to which the halide is attached, and hence it is secondary halide. Next, we'll bring this bromine over here. CH3, CH2, CH, Br, CH2, CH3. Now, again, this bromine is attached to that carbon atom, which is linked with two more carbon atom. So this is also secondary halide. It is also secondary halide. Now, if I bring this bromine here on this carbon atom, it will be as same as that of this carbon atom. No sooner I will write this bromine here, I will have to start counting from this side. So writing down bromine over this carbon atom will also make 2 bromopentane. This is 3 bromopentane. So writing this bromine on this carbon atom will only create a case like this. It is no different. It will be same molecule. So that is why writing down this bromine over here will only cause a mirror image of this molecule. So we can only have 3 positional isomers. Metamers we can't have, tautomers we can't have. Yes, chain isomers we can have. Let us see how. The 5 carbon ring chain can be written as a 3 carbon ring chain plus 2 branches of methyl group. So we can convert it like this. 1, or it can also be a 4 carbon chain plus 1 methyl group. In 2 ways we can divide the 5 carbon atoms. So let us try the first one. 1, 2, 3, 4 and 5. So this is CH3, CH3, CH3. Here I will give one CH2 and I will attach one bromine. Now in this molecule we will see that the bromine which is attached to the carbon atom, that carbon atom is attached with 3 carbon atoms, and hence it is tertiary. Hence it is tertiary halide. But what will be its IUPAC name? For its IUPAC name, we need to write the longest chain. So longest chain would be the one which contains the substituent. So we will take like this: 1, 2, 3 one way, 1, 2, 3 another way. So we can have 3 only. So this longest chain will have the substituents. So we'll name it as 1, 2, and 3. So its name will become 1 bromo, 1 bromo, 2, 2 dimethyl, propane. So we had to make how many? We had to make 8 structural isomers. So we have done 1, we have done 2, we have done 3, we have done 4, we have done. Now let us do 5. Fifth one. Now we'll make a chain of 4 plus 1 like this: 1, 2, 3, 4. Here I can give one methyl group, and here I can give one bromine. H, 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 and H. So its name will be starting from 1, 2, 3, 4. So it will be 1 bromo, 2 methyl, butane, because the longest chain is of butane. Butane chain is the longest chain. Now 3 more we have to do. So for 3 more, I will have to erase these 3. These 3 are understood. Now this 4 plus 1 can also be written as like this: 1, 2, 3, 4. And instead of writing methyl here, I can write methyl here, and I can give bromine here. So in this case, its name will be 2-bromo 3-methyl butane. Now again, this was 6, number 6. Now 7th one. What is the other possibility? Other possibility is CH3, C, C, CH3 here itself, bromine here, and CH3. This will be 2-bromo 2-methyl butane. Its name will be 2-bromo 2-methyl butane. And the 8th one,
Sir?
yes,
Sir, in 6th point, sir, bromo is at the position of 8-1.
it is in one position.
1 bromo is there.
1 bromo, correct. It will be 1 only. You are right. I am wrong. It will be 1. Very good. Who answered this?
Sir, Anjali.
वेरी गुड, वेरी गुड. एकदम ऑपोजिशन स्ट्रांग होना चाहिए, नहीं तो मेरा मोनोपोली चलेगा. ठीक है, वेरी गुड. दिस इज 2-ब्रोमो 2-मिथाइल. ठीक है, तो इसमें नेक्स्ट करेंगे CH3, C, और क्या कर सकते हैं? ऐसे कर सकते हैं, यहाँ पे एक CH3 और यहाँ पे एक ब्रोमीन, H, यहाँ पे एक H. तो क्या होगा? 1, 2, 3, 4. This will become 2-bromo 3-methyl ब्यूटेन. ठीक है, तो इस प्रकार से क्वेश्चन सॉल्व करेंगे तो सारा नॉमेनक्लेचर भी अंडरस्टूड हो जाएगा. ठीक है, और क्वेश्चन सॉल्व नहीं करेंगे और ऐसे बुक खोल के और बुक को देखते रहें, कितनी भी देर तक हम इस बुक को देखते रहें और इसके सेंटेंसेस को कॉपी में लिखते रहें, कुछ हासिल नहीं होने वाला है. लेकिन अगर हम इन क्वेश्चंस को सॉल्व करें सब कुछ हासिल होगा. ठीक है, जैसे कि ये क्वेश्चन है, इसको बनाने के लिए क्या करेंगे? जितने भी बॉन्ड लाइन है, इन बॉन्ड लाइन को तोड़ सकते हैं, लेकिन अगर विजुअलाइज कर पाए तो अच्छी बात है. यहाँ पे एक कार्बन है, कुछ भी नहीं है, यहाँ पे एक कार्बन है, तो ऑर्गेनिक केमिस्ट्री को समझने के लिए जो छोटे छोटे प्रॉब्लम्स हैं उनको सॉल्व करते हैं. उनको सॉल्व करने के बाद जो डिफिकल्ट प्रॉब्लम्स है वो अपने आप होने लगता है. यहाँ पे एक कार्बन इमेजिन करेंगे, यहाँ पे एक कार्बन है, यहाँ पे एक कार्बन है, यहाँ पे एक कार्बन है. काम आसान हो गया, काउंट कर सकते हैं यहाँ से 1, 2, 3, 4. तो नहीं, 1 यहाँ पे है, 1, ये लॉन्गेस्ट चेन हुआ, 1, 2, 3, 4 एंड 5. तो 2-ब्रोमो पेंट 3-इन. अब एल्कीन को क्या कर रहे हैं, एल्कीन को यहाँ पे प्रायोरिटी दे रहे हैं, ठीक है, एल्कीन को प्रायोरिटी दे रहे हैं। यहाँ पे सीखने वाली बात क्या है, इसमें हम ऐसे नेमिंग कर सकते हैं 1 2 3 4, और दूसरा मेथड क्या हो सकता है नेमिंग करने का, दूसरा मेथड ऐसा हो सकता है कि हम इस तरफ से नेमिंग करें 1 2 3 4 एंड 5। तो जो रेड वाला है वो करेक्ट होगा। एल्कीन को लोएस्ट लोकेंट देते हैं, ठीक है, एल्कीन और डबल बॉन्ड इज कंसिडर्ड एज लोएस्ट लोकेंट। तो इधर से काउंट करेंगे तो क्या होगा, 4 पे ब्रोमीन आएगा, तो 4 ब्रोमो।
Excuse me, sir.
यस।
Sir, the screen is not visible.
Sure. Now, is it visible now?
Yes, sir.
Okay. So I was saying that there are two ways of naming this chain. There are two ways of naming this chain. One is you count from this side 1 2 3 4 and 5. Another way could be you count from this side 1 2 3 4 and 5. So which one will be correct? The red one will be correct. What is the reason? The reason is priority rule. Okay, so the red count is correct. Wherever alkene will be there, that alkene will be given priority as lowest locant. Okay, double bond and triple bond is given lowest locant, means number of the position. So in this case the name will be 4 bromo, 5 carbon atoms are there, so pent 2 in. Again in this molecule we'll apply the same concept. We'll count from this side 1 2, this is 3 and this is 4. So 2 bromo but 1 in. On the first carbon atom itself double bond is there. On the first carbon atom double bond is there. इसको सीधा करके भी लिख सकते हैं. इस मॉलिक्यूल को सीधा करके लिखेंगे तो क्या होगा, ये फर्स्ट कार्बन है, डबल बॉन्ड, ये सेकेंड कार्बन है, सेकेंड कार्बन से एक मिथाइल ग्रुप निकला हुआ है, फिर थर्ड कार्बन है, थर्ड कार्बन में एक तरफ ब्रोमीन है, एक तरफ H है और एक तरफ CH3 है, ठीक है, और यहाँ पे H, यहाँ पे H. इसी मॉलिक्यूल को टेढ़ा मेढ़ा करके लिखा हुआ है, क्यों? क्योंकि जो ऑर्गेनिक कंपाउंड्स होते हैं उसमें कार्बन टेट्रावैलेंट होता है, तो उसका अरेंजमेंट जो है वैसे जिग जैग करके होता है, ठीक है, ये जिग जैग अरेंजमेंट के कारण जो है इन मॉलिक्यूल्स को ऐसे लिखा जाता है. So these are bond line notations. Similarly, we will see this molecule. I could have taken this in the white screen, but these pictures will not come there. Again, counting has to be done in such a way that the alkene gets the lowest locant 1 2 3 4 and 5. So it will be 4 bromo pent 2 in. At the second carbon atom double bond is starting. So 4 bromo At the third carbon atom, one methyl group is there, 3-methyl, pent 2-ene. Similarly, you can do this molecule as homework. Try this molecule as homework. We are not left with any more time. And also do visit the videos which I am putting up, because so many things are there which cannot be taught in 45 minutes. So we are doing some live interactions, and we are also putting videos which are all of same topic only. So do visit the videos also, okay, whenever you get time, in the playlist of haloalkanes and haloarenes and in the organic chemistry.